What if the most valuable AI breakthrough of 2026 isn't a new model, but the infrastructure architecture that finally makes agents boring? Not boring as in useless, boring as in they don't crash during month-end close, they don't leak API keys into Slack, they don't hallucinate your customers' data into a training set, they just run for hours, unattended, auditable, compliant. OpenAI just declassified the production architecture they've been running internally for Codex and with customers like Glean, Virgin Atlantic, and Cisco. It's not about the flashier models, it's about the systems that don't break when you stop watching. Today, I'm revealing the 5 architectural secrets that let OpenAI agents consume 7 million tokens in a single workflow, why Glean saw an instant 18% performance boost, and the specific patterns that separate pilot projects from profit centers. If you're building AI that handles revenue-critical work, this is your new playbook. OpenAI's February blog post is a post-mortem from the trenches. They've been running this architecture for over a year with enterprise customers, and now they're revealing the non-obvious patterns that actually work in production. These aren't features, they're liability containment systems designed for workflows that touch real money. And the first one changes how you think about prompts entirely. First secret, stop treating prompts like artisanal crafts. Skills are versioned business logic, standard operating procedures that survive employee turnover and model updates. A skill is a bundle with a Skills.md manifest containing front matter instructions, templates, and crucially, negative examples. When an agent needs to perform complex work, it doesn't improvise, it loads the skill and follows the playbook. Glean, the enterprise search unicorn, implemented a Salesforce-oriented skill using this exact framework. Evaluation accuracy jumped from 73% to 85%, and the time to first token dropped to 18.1%. But here's the counterintuitive part. Initially, skill triggering dropped 20%. Why? Because the AI couldn't figure out which skill to use and when. The fix was adding negative examples, explicit "don't call this skill when" instructions. This is product management for AI. You're not engineering prompts, you're designing decision boundaries. In 2026, companies still treating this as better prompting are bleeding compute costs on misfires while competitors scale deterministically. Cisco, Duolingo, and Vanta are already using Codex agents with this skills architecture. Cisco automates network configuration scripts. Duolingo generates practice exercises and verifies translation code. Vanta writes compliance configs and parses audit logs, all using versioned, auditable skills. But knowing how to do the work isn't enough. You need somewhere to actually do it without burning down your infrastructure. That's secret 2. The second secret, Shell isn't just code execution, it's a liability containment system with a hard boundary. OpenAI's hosted containers let agents install dependencies, run scripts, and write artifacts, but only to the data folder. This creates a review boundary between tool execution and production systems. The model writes to the disk, you verify, and then deploy. Virgin Atlantic and Gap piloted Codex agents for customer service automation and internal tooling. Virgin's CFO specifically cited productivity gains across various functions using this hosted shell approach. But here's the architectural insight that matters for your compliance team. The agent never touches your production database directly. It produces artifacts. You audit those artifacts. You promote them through your existing CI/CD pipelines. The security model. OpenAI implements 2-layer networking. An org-level allow list sets maximum approved destinations. Every request must include a network policy that's a subset of that list. If a request includes domains outside the org list, it throws an error. Add domain secrets for authenticated calls. Credentials injected via sidecar. Model sees only placeholders like API key. The model never sees raw credentials ever. This is why banks and healthcare companies are comfortable with this architecture. Now you've got procedures and a safe place to execute. But what happens when your workflow runs for 4 hours and it hits the context limit? That's where most agents die, unless you know secret 3. The third secret. Compaction is the invisible infrastructure that makes long horizon economics viable. Previously, long workflows hit context limits and crashed, or required manual context surgery. Server-side compaction now automatically compresses conversation history when the threshold crosses. No separate API call, no interruption. OpenAI demonstrated this with a 3D racing game where Codex consumed over 7 million tokens in a single session, acting as designer, developer, and QA tester. Without compaction, that workflow dies at hour 2. With it, you get completion. Now, let's understand why this matters for business. Meter research shows AI task duration capability has doubled every 7 months since 2019. By 2030, we're looking at multi-day autonomous projects. Compaction is the memory management that makes that timeline commercially viable. For procurement teams, this means that agents can handle month-end reconciliation workflows without losing track of exceptions. For legal teams, due diligence that runs overnight without crashing. For DevOps, infrastructure migrations that complete instead of hanging. So, you have the procedure, the container, and the memory. But how do you actually ship this without getting fired by your security team? Secrets 4 and 5 are about the deployment philosophy that makes this production ready. Secret 4, the local to hosted gradient. Start local for fast iteration. Same tool semantics, you control the machine. Move to hosted containers when you want repeatability, isolation, compliance. Keep skills identical across both these environments. This acknowledges a hard truth. Developers hate vendor lock-in during iteration, but enterprises demand isolation for compliance. The same skill bundle works in both modes. Your workflow stays stable as execution environments change. Secret 5, deterministic routing. When you need reliability over flexibility, explicitly tell the model. This turns fuzzy routing into a contract. For high-stakes workflows like financial reconciliation, compliance reporting, customer data handling, you don't want the model deciding which procedure to follow. You want deterministic execution of a versioned, audited skill. OpenAI just revealed their production architecture, not because they're being generous, but because they want this to become the enterprise standard. If you're architecting AI systems in 2026, you have 2 options. Build on this foundation or explain to your board why your automation requires constant babysitting. Now, if you're watching this and thinking we need to implement this but don't know where to start, I help businesses of all sizes with exactly that. I provide AI strategic consulting to companies building production-grade agent systems. Check the email in the description and reach out. Hit like if you got value from this breakdown. Drop a comment if you're already implementing skills-based architectures. I'd love to hear what's working, and subscribe. See you in the next one.